Hello students, so today we are going to study about BLDC motors, right? So in DC motors, while you have studied the DC motor, you have seen that brushes are required to convert AC current generated in DC generators to a direct current, right? Or vice versa for DC motors. And you have also seen that a field winding, it is used to produce magnetic field, right? Now what happens in BLDC motors, that if this winding, this field winding, what it is actually producing magnetic field, right? So if this winding is replaced by permanent magnet, what will happen? The rotating magnetic field is generated without the need of separate winding, right? So what will happen because of this? What will happen? Losses will be eliminated, right? So over the years many advancement has been done in BLC motors, and which permanent magnets are used? They are alloys like neodymium iron boron or samarium cobalt, right? So these are the permanent magnets which are used in BL and DC. Now what are some of the advantages of using permanent magnets? So if permanent magnet are placed on rotor, what will happen? The armature winding will be stationary. Remember, here we are comparing it with DC motor, okay? So the armature winding will be stationary and the brushes can be removed. So this has got two advantages. First, resistive losses are completely eliminated, and second is maintenance and safety issues are also taken care of, right? Thus this DC motor with permanent magnet without brushes is called brushless DC motor, or you can call it simple BLDC motor. Okay, now let us understand the operating principle. Now this is diagram of what? Of a simple DC machine, right? So you can see that there are two axes. This is quadrature axis and this is direct axis, and the fields here, they are created, they are orthogonal with each other. What is orthogonal? At 90 degree with each other, right? This is the construction. Have a look at it. This is the construction for a simple DC machine. Now have a look at what happens in case of if this winding is replaced by permanent magnet. Now this when in a standard two pole rotor is rotating under an armature, when n pole passes under completely across a conductor, so we need something to change the direction of current in that conductor, right? So what happens in case of conventional DC motor, the number of commutator segment is equal to what? Number of conductors, right? So what is needed? There is a need to change the direction of the supply, right? What happens in case of BLDC? This direction of reversal is done via power electronic switches, and now the instant of reversing, as the direction is a function of position of motor, so we require something to sense the position, and hence sensing of position means it is required, right? Which is it is fed back to the power electronics drive, which drives and controls the supply which is given to the motor. Okay, so have a look at the complete block diagram of BLDC motor. It looks like this, right? Have a look at it. Okay, this is BLDC motor. Okay, this is BLDC motor, and this is the position sensing arrangement, right? This is current sensor which senses Okay, and this is the position sensing arrangement, and this is microcontroller, okay, which sends back which sends back that how the rotor has to be positioned, and it feeds it back to the inverter circuit, right? So the advantages of BLDC are high power density, and this is happens because of this permanent magnet, and they have got greater efficiency, okay, then low maintenance cost obviously, and other than that I'll also send you notes of it. Okay, so that's all about BLDC motor. Thank you.